Hi everyone, my name is Itzik Reich. I'm Vice President of Technology here at Dell EMC. And with me, I have Paul Mitchell, who is our Field CTO for Data Protection Solution. And today we're going to talk about accelerating adoption for VMware Tanzu, enterprise storage, and data protection options for Kubernetes workloads. With that, let's start with the very beginning. In the beginning, we used to have bare metal servers that used to run a single operating system on each one of these servers, and probably a single application that ran on this operating system. Then came VMware with a radical different thinking and say, you know what, why don't we consolidate all of these applications that don't generate a lot of CPU and memory consumption and run a very thin layer of an hypervisor on the top of that bare metal server. And then each VM will consume its own operating system and memory and CPU cycles, but together it can actually stage a lot of these bare metal servers that don't do a lot. And that used to resonate quite for a very long time, including today. But then in 2015 came a small startup called Docker and said that maybe there is even more efficient way of running applications on the top of the bare metal servers, but basically running single operating system on that bare metal server. But instead of running an hypervisor on the top of it, what they did is basically fork, if you will, the kernel of that operating system, and each one of that fork ran its own application separately. So each and every one of these applications is not aware of the other one. And by doing so, you can actually save a lot of this cost on this operating system that runs on the bare metal server. And that is an absolutely valid way of running containers today, but there is also a new emerging way of running containers on the top of the bare metal servers, and that's the way that VMware chose to do, which basically still run an hypervisor, a very thin layer of an hypervisor on the top of the bare metal server, but on that hypervisor run the Docker runtime, and by doing so, you can basically enjoy both of the worlds. You can still isolate each one of the container runtime from the other containers that are running on the bare metal server. But things like high availability, vMotion, DRX, all of these features that we used to know and love from the VMware still exist. So you benefit from them immediately while running them on the top of the hypervisor with the Docker runtime. And if I then compare and contrast this to the storage management world, still today, people are probably managing the storage array from the user interface. So in this example, you see our PowerFlex, our software-defined storage UI. So to the left, you can see how to provision volumes, and to the right, you can see a way how to monitor the storage array. And automation, if you will, was probably script via the storage array CLI command, the way to automate and accelerate, for example, volume provisioning. That was the best way of automating the storage array using native storage tools. The thing is that everything is different today. People expect to treat your storage just as a line of code, just like everything else that evolves around writing and development and writing application that will run inside your servers. So storage is just another element, if you will, that is important, but it's as important as any other line of code for the developers that are basically developing the software on the storage and the compute and everything else. So for them, they just want to, with a single command, do everything that evolves around storage management without touching the storage user interface. And into that world of the Docker runtime came many orchestrators that did exactly that. And the leading orchestrator that basically has won the war big time is the Kubernetes orchestrator. And there are many reasons why Kubernetes succeeded, and it's now become the de facto orchestrator that is running on the top of the Docker runtime. Some of the reasons are full automation around everything. It starts with self-healing. So if a container fails, Kubernetes will know how to spin up a new container that will mimic the failed container workload. It's very easy to upgrade the entire stack where you go with Kubernetes. It's very easy to scale your workloads. So think about database that comes, for example, Christmas. It's very easy for you to your retail shop you just spin up another database that will automatically load balance itself within the rest of the databases in your backend and will fulfill your user request just for that time. And just like you can do spin up and scale up, you can also scale down if your workload demands are shifting, which is something, again, that is very, very new to the way of writing application these days. On the storage management, which is our focus in this session, is really everything around storage orchestration. It is very, very easy to provide storage management capabilities directly from within Kubernetes. So let's actually talk about those options. At the very high level, the thing that you are looking for in a storage array when you work with Kubernetes is a plugin called CSI plugin, which stands for Container Storage Interface. The Container Storage Interface really provides you the ability to extend your existing storage infrastructure into the Kubernetes management itself, and by doing so, provide microservices help and assistance to your running containers. Now let's go a little bit deeper into the architecture of the CSI plugin itself. How does it work? In a nutshell, if using a block storage, for example, a volume in the language of Kubernetes will be a persistent volume, which basically means that when you're a Kubernetes administrator, you log into the Kubernetes interface and you claim actually a persistent volume from within Kubernetes, which stands for PVC, persistent volume claim. And in advance, if your storage array speak, Kubernetes will answer with a persistent volume that will be provisioned for that container that you just spin up in the system. However, this is just the basic offering. Modern storage arrays such as PowerFlex or PowerStore or PowerMax in our portfolio can also give you the ability to provide unique capabilities that are coming outside of just the provisioning operations. For example, in the case of PowerMax and PowerStore, you can also designate quality of service for your running containers. So you will know that none of these containers that will be maybe spin up will manipulate the entire storage resources for that specific container workload. Now, let's see how it's actually all tied into VMware, because up until now, we only talk about Kubernetes itself. VMware in 2020 came up with vSphere with Kubernetes, which can be part of the VMware Cloud Foundation, but it can also be consumed in other fashions. VMware basically invested a lot in adopting Kubernetes and attaching it to the very core of the vCenter interface by both the management element and also the ES6i kernel itself, providing you really an holistic approach to manage Kubernetes workloads directly from within vCenter. So if you're a vCenter administrator, the familiarity of the UI will be immediately on the spot. If you're a Kubernetes administrator, you can still continue using the kubectl CLI, basically creating container pods, creating and storing them as you go. From a storage management, which is what we are discussing now, really there are two options that your storage array can interface into vSphere with Kubernetes. The more traditional way is to use VMFS data stores. Pretty much every storage array under the sun today provides VMFS capabilities, nothing new here. However, the more modern way, if you will, the first-class citizens option is really to provide volumes and storage volume to the VMware with Kubernetes via vVols, VMware Virtual Volumes. We're going to talk about the benefits in a second, but that's something to bear in mind that both of these options are available to you as a customer. And the third thing that I want you to take out of this specific slide is that in the case of running vSphere with Tanzu Kubernetes Grid, we, the storage vendor, do not provide a CSI plugin for you, just like we will in a vanilla Kubernetes distribution. Because the CSI plugin in that case is provided for you by VMware. We interface into VMware Tanzu Kubernetes Grid via vVols or VMFS, as we mentioned before, talking into the VASA element that acts as a bridge, as a communicator, if you will, between the storage world domain to the vSphere and the Kubernetes domain. Now let's talk about why should you choose VMFS or maybe another approach. So if you go with VMFS, which as we said, pretty much every storage supports today, you probably want to stick with statistic provisioning. And in a second, we're going to talk about what it is, but something to bear in mind that when a container is being brought up to the world, the data of that container itself runs on VMDK file, just like any other VM. So you can look at the VMDK file, take a snapshot of it, move it around, nothing new. Those are, again, the benefits that we discussed in advance. Why should you choose to go with, for example, VMware with the vSphere hypervisor beneath? Because it's still using the VMDKs as before. While using VMDKs, you have two options that you can provision your running containers: static provisioning and a dynamic provisioning. A static provisioning, which is really a manual provision, basically means that the vSphere administrator or the storage administrator, if you will, needs to prepare in advance the VMDK volume, present it to that running container, and then when the container is being brought up, it will use that specific VMFS with that specific VMDK. If you delete a container, for example, the VMDK file will not be deleted automatically. Or maybe should you decide that you need more capacity, you need, again, in advance to discuss these storage needs with your storage administrator, prepare these storage volumes, format them as VMFS, and then finally present them as VMDK file. So you probably already start to say to yourself that maybe that doesn't really scale, and it requires a lot of manual intervening, and you're absolutely right. However, it is an option for storage arrays that do not support vBrownBag, just to go with VMFS. For storage arrays that do support vBrownBag, as we said, such as PowerMax, PowerStore, and PowerFlex, there is a much, much better way to do it, which is the dynamic provisioning, which is done with vBrownBag. Here, the way to think about it is like a menu. Imagine yourself going to your favorite fast food restaurant. You're probably going to see a catalog of a couple of your items that you can order, and the same apply here. You probably want to designate a couple of different service level agreements. In the language of Kubernetes, those are known as storage class. And storage class can really mean many things, but in the context of storage, it is very likely to mean quality of service, for example. Maybe you want to designate the size of the volume with specific IOPS that are tied to that specific storage class. So when a Kubernetes admin will now go ahead and provision, for example, their database application, the only thing that needs to be pre-agreed in advance is the storage class that you want to provision, how much performance maybe is associated with that specific container. And then, I'm going to show it in a demo in a second, once the vSphere administrator logging into vCenter with the Kubernetes UI, it will automatically provision that vVols from within the underlying storage array. We're going to use PowerStore in our example, carve up that volume, attach the quality of service to this vVol or vVols if the running container contains more than one volume. And by the time that the container will be shut down, you have options such as keep those volumes to stay up and running, or maybe delete them if you will. And all of those things are done automatically for you. The only thing you need to prepare in advance is this service catalog. What's the SLA that you want to designate in your organization? Most of the customers that I'm talking to are sticking with those three. They don't want to make it overly complicated because then again, there are too many reasons to consider, and they stick with gold, silver, and bronze, which really means different quality of service that can be applied for the running containers. Now, let's take a look on how it can actually be applicable to real-world cases with real storage arrays under our portfolio. To the left, you can see our PowerFlex storage array, which is our software-defined product. Let's assume, just for the sake of this example, that I assign the gold service level for that storage array. Again, gold can mean many things, but for the sake of the example, let's assume that I actually want to provide it the best performance possible. To the right, you see another service class, storage class that I created, and I assign it a silver storage class. And in this case, I'm using the PowerStore storage array, which is our newly announced mid-range storage array. I specify the storage class, and now as a Kubernetes admin, I'm just logging into the Kubernetes CLI or UI, if you use the UI, or vCenter in that case. And now I'm only selecting the gold service class, which if you recall, we already pre-assigned and pre-agreed in our organization that we're going to select or make available as an option. And if I'm now choosing gold, Kubernetes and VMware will be smart enough to interface via the VASA provider to the storage array that exposes its capabilities and the one that we agreed upon in advance that has the gold service class. And in this class, in this example, if you recall, what we are using is a PowerFlex, so it will automatically know to go to the PowerFlex storage array, provision the volume from it automatically. So nothing needs to be done here manually. So let's see how it actually looks using the PowerStore UI. So let's see a demo, how it all looks and how it's all tied together with the vVol interface with VMware Tanzu Kubernetes Grid. Let's see a demo. Right, so let's see how it all looks together with DELL EMC PowerStore and VMware Tanzu Kubernetes Grid. What we see here is a Tanzu Kubernetes Grid deployment cluster that we deployed in advance, which now can be shown here as the WCP cluster. And if we go to the vSphere client, we can now go ahead and actually prepare and tell Tanzu Kubernetes Grid that we're going to use the PowerStore storage for that particular workload. And if you recall, what we now need to do is to specify the storage policy, storage class in the language of Kubernetes that is going to be exposed via PowerStore. We're going to use dynamic provisioning, so we're going to use vBrownBag, which is why we are now ticking this box that basically tell PowerStore in the context of vSphere to use vBrownBag for the Kubernetes running workloads. PowerStore is a very advanced storage array, and one of the capabilities that it surfaces is quality of service priorities, if you recall that we discussed earlier. So we are just going to create a vVol rule known as high QS policy, which means that if the Kubernetes administrator will go ahead and select I for its storage class, it will automatically know to apply the high quality of service option from within PowerStore. And of course, you can use the low, medium workload, depends on what exactly you want to run within your Kubernetes workloads. So now that we specify the VM storage policy, the next step for us is to go ahead and actually use PowerStore for that particular workload. So we're going to go back to the vSphere UI, to the workload management, create a new namespace, which is a terminology in the Kubernetes world. Think of it like as a new cluster that is designated to run that particular Kubernetes workload. And we just create the namespace here. As you can see, it has its own a unique UI, which is part of the vSphere. And now we're going to direct that namespace to use the PowerStore vVol with the IQS policy that we just created a step before. When this is done, we now log into the Kubernetes kubectl command, which is the familiar tool for the Kubernetes administrator. They are very unlikely to use the vSphere UI. They're using the kubectl. But as we said, each and every one of the parties has its own CLI or interface that they are going to work with. And now what we're going to do is to actually run the VMware CSI that we told and explained that is being used here. In that case, well, because we're using vSphere with Kubernetes and Kubernetes Grid, it is not using the storage CSI, but rather the vSphere CSI. And we're going to show it and tell it to use the PowerStore storage class that we designated before. The next step is really to bring up an application from that particular namespace running on PowerStore, which is what we're going to do here. We are actually going to run a Yugabyte database. If you're not familiar with Yugabyte, it's a next class database that, unlike traditional databases, can truly scale out. You can literally, within a click of a button, tell it to create new instances of that database, and it will automatically spread the load between all the available containers. That's the PowerStore UI. What's unique about it that even the UI itself has a very tight integration within vSphere vVols that, as we mentioned, is what we are using in the case of VMware TKG. And what you are now looking at is every time that we bring up a container, that container will use a couple of vVols. There will be the config vVol, the data vVol, the sock file, of that running VVol-based VM. And it will actually run and show you the name of the running container workload that we just specified. So in that case, we call it Tomer, TKG01. So you can actually see the container name is actually the prefix for all the running VVols in the system itself. Lastly, we can also see that we are running a scale-up architecture, as we mentioned before, which is what we see here. So we wanted to scale the Yugabyte database deployment. So literally within a click of a button, it will create more containers and of course attach new VVols to them. And which now you can see from within the storage array of PowerStore here. So if we now go to the storage container to the VVol tab, we will see that more VVols are now associated with that running a workload because we just decided to scale it up. And look at how easy it is to scale out the container workload and how easy it is to also scale the VVol implementation. We did a lot of optimization within PowerStore itself to be able to really provision many VVols at one go because we recognize that's a very known scenario that you want to burst your running containers and you want to do it in a very quickly manner. And so that was the demo about how to use PowerStore VVol with VMware, Tanzu, Kubernetes, GUI. With that, I want to introduce Paul Mitchell, who is our field CTO for data protection solution, who is going to talk to you around the options to run data protection for Kubernetes workloads. Paul, the ball is over to you.
Thank you, Itzik. Appreciate it. That was a great insight in how obviously we can actually interact with storage natively with Kubernetes. I'm actually going to spend the rest of the time today's presentation talking about data protection. This is normally quite a strange conversation to have when it comes to Kubernetes. As customers move into this agile workload, there's a huge push in the industry to move things into an agility standpoint, moving platforms very, very quickly. And one of the things that we find in the conversations that we have is ultimately that people are ready to push applications where the traditional IT operations teams are not ready to do so. So if you look at this interaction that I'm sharing right now, is that obviously the developers are willing to push the application very, very, very quickly into the industry, but obviously the IT guy has operation considerations when it comes to compliance, backup, and disaster recovery when it starts to move into a different agile-based environment. I'm going to spend the rest of the time talking about PowerProtect. PowerProtect is Dell EMC's or Dell Technologies data protection strategy application that protects virtual machines natively, as you expect, enterprise applications, as well as container workloads that Itzik has just basically covered for us. We're actually working in conjunction with PowerProtect with Velero. Velero is obviously a VMware-based technology that provides integration into Kubernetes infrastructure using the kubectl API. PowerProtect allows us to protect everything at the namespace layer and provides functionality that we can protect namespaces. We can actually restore namespaces to the same cluster, to a new namespace, or an alternative cluster. And we can also include or exclude the PVCs, or the persistent volume claims that Itzik covered earlier on today. We provide the ability to take not only advantage of the CSI interface, but also to talk about some of the functionality that we bring to the table when it comes to integrating further with VMware. PowerProtect allows us to not only maintain and give you a choice of how you wish to protect the data when you're running in container-based workloads, but also the agility to be able to provide different interfaces, because that's one of the things that we're seeing in the industry is obviously people want a choice, and we'll cover that in the next couple of slides. Obviously, really around governance and compliancy, when we're talking about workloads, we want to make sure that we can recover these workloads. And what we've done with PowerProtect is predominantly taking advantage of, as I said, the Velero integration, and we'll cover that further, but also leading into Dell Technologies deduplication data protection strategy as well. So now we can provide best integration and best of breed solutions when it comes to Kubernetes and data protection workloads from a consistent messaging and a consistent tool set. I mentioned a choice. Well, choice ultimately is if, again, do you want to use kubectl? Do you want to use a native GUI-based interface? Or do you want to leverage things like basically the REST API? We're giving you a choice of where you wish to do your level of management as you need. It gives you the ability for orchestration to be able to provide it through the interface, And we can do some nice things around there, looking at basically audit trails and compliancy and meeting business requirements, but also the ability for effectively the Kubernetes administrator to still be able to do backup and recovery, but doing that natively within the kubectl API. We can take advantage of labels, and labels obviously beginning to label the namespaces. Just think about them like you do tags or key value pairs that I can associate with the namespace so that I can do dynamic agile protection of those new namespaces and pods and containers as they come online. Simply by just labeling those using the CLI within PowerProtect, I can simply discover those very quickly and agile, put them into a policy to be able to provide an ongoing protection strategy around that. As I mentioned, with everything that we're doing in the organization, rest is very first and forefront into the technology choice. So we're giving customers a choice of where they want to play into this to provide an enterprise class solution for their data protection needs. If you look at really Kubernetes as a platform, Kubernetes is really orchestration of containers, and Itzik again did a great job of talking about where that sits. But where we feel here is that obviously, protecting just a snapshot or just effectively the PVCs that we talked about is only part of the solution. And with PowerProtect, we're actually able to obviously protect not only the traditional PVCs and obviously that using the CSI framework, so again, providing the container storage interface capability to provide a snapshot mechanism, but also to be able to protect things that you wouldn't anticipate part of that. So again, as you rotate through your agile environments, things will change, like, for example, deployments and, for example, secrets, and obviously just replica sets and things will change. And with the beauty of actually integrating both Velero into PowerProtect, we can take advantage of protecting both of those. So we're actually giving you the ability to do a very flexible schema to be able to protect the data, but also to be able to restore it with its current control sets into any environment you need. We actually deploy 2 namespaces within the Kubernetes cluster. This is part of the PowerProtect Data Manager. One of them I already mentioned is the Velero. And the other piece of this is the actually PowerProtect namespace that actually provides a controller for actually orchestration and then data movers. One of the things that I mentioned earlier is obviously we're leveraging Dell Technologies first and foremost enterprise class data protection strategy in the sense that we're actually providing deduplication and compression at a source layer before we move anything into protection storage. And this is all part of this orchestration that we provide with the PowerProtect engine. If I look at the integration point, we actually work with PowerProtect predominantly with any CSI implementation that has been validated. CSI as a standard is still being ratified and is very early in some distributions, but effectively PowerProtect in conjunction with Velero using the CSI framework allows us to be able to protect those orchestrated workloads, again, using that technology. I want to talk a little bit further about where we've gone to the next level with VMware, and this is the reason why you guys are attending today's session, and we really appreciate your participation today. But from an integration standpoint, specifically around VMware Tanzu, is that we've added some feature functionality which is different to everything else. So again, Itzik mentioned already how effectively we're using the VMware CSI framework for integration with storage. We're still using that, but one of the nice things that actually came into play, and 2 things I want to talk about from this, is that we do have our ability to manage this again from the cloud native control plane inside VMware, but also we give you the ability to use a new feature that was implemented in 6.7 update 3, which is actually called first class disk. First class disk is a functionality to be able to take a snapshot of that disk without being attached to an instance or a running machine. And that was a great feature functionality that was asked for many years. And we're taking advantage of that with effectively what we're doing in conjunction with Tanzu. Secondly to that, we're actually using the same data mover technology within the same namespaces, but this time we're actually using deduplication in conjunction with change block tracking. Change block tracking is a very capability that's been alongside VMware for the longest time. And here at Dell Technologies, we've been using that for efficient data protection backup strategies of virtual machines. But now we're bringing the same capability of that into effectively protecting containers. So now that we're only sending the unique data changes post deduplication and compression to the protection storage. Just to give an example of that, by looking at a couple of screenshots here within PowerProtect, if you look at the left-hand side, you can see that part of the first policy from this particular snapshot, the first data change rate that I sent was 108 megabytes. But subsequently, the second backup as it continued was only sending 76 kilobytes worth of data change. Again, these are the things that's happening with the integration, again, between Velero and obviously PowerProtect, and obviously the integration inside VMware, where we can take advantage of change block tracking You can see this is a huge efficient capability that provides that with a full orchestration engine, providing protection of your Kubernetes solution end to end. I wanted to end today just to kind of wrap up really where I talked about from a data protection standpoint. Again, one of the things that we want to leave you with from a messaging standpoint is that with Dell EMC or Dell Technologies Power Protect solution, we're able to give you an enterprise class solution to provide you a whole private cloud infrastructure, whether that be virtual machines, enterprise applications, and of course, containers that we've discussed today. We're obviously best of breed, obviously better together, working in conjunction with VMware to provide the best solution, taking advantage of feature functionality where we possibly can. And again, as I said, we've already mentioned using it in conjunction with Valero and in conjunction now using CSI integration to be able to provide best of breed solution. Thanks for joining today. We appreciate your participation and I hope you gained something from it today. Thank you, guys.
Thank you.